Okay, this is going into week 5 in Precalculus. We're going to talk about section 4.5, which is getting a deeper understanding of the graphs of the sine and the cosine functions. I'll break this section up into 2 videos. So I'll call this section 4.5 part 1, where we're going to talk about understanding the graph of y equals sine x and the variations of y equals sine x, and then vertical shifts of sine and cosine curves we'll talk about later. Okay, so we'll break this up into essentially the sines and then the cosines. Okay, so these are the examples we're going to do. I'm going to talk to you first about the sine function. So the graph of y equals sine of x. So first of all, hopefully everybody has a good understanding of what the sine of x looks like. It's a nice wave type function. As a matter of fact, in applied mathematics, sines and cosines often model waves for us: water waves, sound waves, electromagnetic waves, different kinds of waves. So the range is -1 to 1, right? Of the simple y equals sine x, the range is -1 to 1. And what we often say is that the amplitude of this function is 1. The height of the wave, the highest it goes, is 1. And it always goes above or below 0 the same way. The domain, of course, is -infinity to infinity. This shape repeats forever. But notice that it repeats over a period of 2 pi. So every 2 pi, it repeats itself. So we have this wave function. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, the sine of 2 pi is back to 0, and then it repeats itself again, on and on, forever and ever, and likewise in the same direction, in the negative direction. Now, what do we do with amplitude, period, and phase shift of a function? So let's say we look at the sine function, and now we're not talking about vertical shifting. We're talking about other kinds of shifting. So when we have the sine of something like this, we know we're shifting to the right or the left. That's a horizontal shift. And if I put another number in front of it, that tells me that the height of that function, the sine function, is no longer 1. It's the height of this guy, the absolute value of that guy, actually. So the amplitude is the absolute value of that. That's the highest it gets above 0 is the absolute value of that. If it was negative, it means it would reflect it, right? And so it would go down first. The period is 2 pi over b. So you figure out what the coefficient of x is here, divide that, take 2 pi and divide it by that coefficient, and that tells you what the period is. The phase shift is this c over b. Notice it has to be in the form of minus some constant c divided by b. So you have to figure out what c is by its minus that constant divided by b. And if c over b happens to be a positive number, that means we're shifting to the right. If I negative something that's positive is shifting to the right. If it's negative, if c over b is a negative number, we're shifting the whole thing to the left. Okay? So, for example, let's determine the amplitude, period, and phase shift of y equals, no, shoot, I shouldn't be doing, I gotta, that's cosine. Let's go down to sine. Let's do example 2 first. So let's graph y equals 4 sine of 3x plus pi over 2. So the amplitude of this is the absolute value of this coefficient in front of the sine. That's the height of it, right? So it's the absolute value of 4, which is 4. The period is 2 pi over b. b is the coefficient of x, so 2 pi over 3. That means instead of the period being now 2 pi, it's going to repeat every 2 pi over 3. And the phase shift is this pi over 2. Now it's pi over 2 is the c, right? Divided by b, right? So it's pi over 2 divided by 3. Actually, that should be minus a minus pi over 2, right? So this should be minus pi over 2 divided by 3. That would be minus pi over 6. That's a mistake in my notes. Please make sure you note that. This should be minus pi over 6. Remember, it's b times x minus c. So c is actually minus pi over 2 divided by the b. So this should be minus pi over 6, which means that's a negative number, so it's going to be shifting it to the left. So I actually have this off a little bit. I have this shifting right. It should be shifted to the left. This whole thing should be shifted to the left. This pi over 6 should be over here at minus pi over 6. Everything should be shifting to the left. Otherwise, it looks the same. So what I usually do when I graph this is I just put tick marks. Then I draw the function so it covers, I have one tick mark in between here like this. So I'm I'm essentially plotting 5 points. This point, this point, this point, this point, and this point, and then saying it repeats after that. Now, this should have been drawn over here at minus pi over 6. At 0, it should have been up here at 4. At pi over 6, it should have been back down at 0. At pi over 3, it should have been down here to minus 4. Okay, at pi over 3, it should have been down here to minus 4. And at pi over 2, it should have been back up to 0. All right, so it should have went from minus pi over 6 to pi over 2, this same shape. So I shifted it the wrong way in my notes. Please make note of that. Okay? All right. I'm going to stop there and then go talk about the cosine function and go back to the next example, the previous example.